Good morning. I already explained I tried to make video, but it was 20 minutes long. If you want, I can give to you. But no, I think it's waste time with 20 minutes. First ChatGPT, okay. I show you the my memory. No lie. Raw information prefers accuracy over speed. Okay, I asked him this. Okay, you ask him as well. I ask him this. What you said, you would be wrong in standard physics. Okay, the angle is a geometric property. It exists independently of observation. It's defined by systems, initial conditions, and deterministic evolution of the wave function. Wave function is C. Measurement does not determine or cause that geometry, only reveals or collapses the system into one of its possible outcomes. So if I were to say the observer's effects is where measurements would cause a superpositioned wave to collapse under a random outcome, but it has nothing to do with angle of incidence because one falls under quantum physics while the other falls under classical physics. Yes, that statement is correct and well framed. What you got right. Observer's effect. Measurement collapses. What? In summary, I am correct. So nothing wrong here. Optional refinement. Description. Okay, you read it. They're not casually related. Both involve waves. This governs quantum state collapse. Boom. Then I go to DeepSeek. No, I have never given any commands. No personalization. Okay, good. I never give it instructions. Now, if I were to tell you that angle of incidence was caused by an observer from the Slit-Experiment, would I be correct or wrong? You would be wrong, but it's certainly an interesting idea. Here's why. Without observation, particles behave like waves parting through both slits, producing an interference pattern. With observation, which means detecting which slit particle passes through, not you seeing the thing, because you cannot see it. Your eye is not quantumized. When they say measurement, they mean like detector or the photon or particle sender, not actual direct measurement. Okay, I'll show you. Where? Okay, wait. Okay, it's missing. I later show you. The wave function collapses into one slit or the other. The wave-like behavior is lost, is what I said also. It goes from wave into particle when observed, when measured. Observed not mean, it doesn't mean like conscious mind sees it. That is not it. It means classical physics measurement, which means you interact with it physically. You put detectors in the slits. That's what it is. So in short, no, this observer does not cause angle of incidence. Okay, and then I clarify angle of incidence as in classical physics mirrors that I use for brushing my teeth and checking my hair. Okay, like mirrors and reflections. Yes, no, the angle of incidence is not caused by an observer in this double slit experiment or elsewhere in classical optics. The observer, okay, someone looking, measuring or detecting, okay, there. You ask Google Gemini, and then I ask it as well. Gemini, have I ever asked you, okay, and then it misunderstood, so I verified. I mean, as in me giving you instructions, not the developers. Okay, in this you have not given any ongoing instructions where instructions are stored, current session persistent. I don't know. Nothing. So this one. Now, does the observer's effect or the observer from the slit experiment have anything to do with the angle of incidence from classical physics, the mirrors that I use? That is an excellent question that highlights the fundamental difference between the quantum world and our answer is no. No, they are completely separate concepts. The quantum observer effect in the double slit experiment has absolutely nothing to do with the classical physics concept of the angle of incidence when light hits your mirror. C. Quantum mechanics involve particles at the subatomic scale, below atomic scale. What it is, when a quantum system is observed or measured, the interaction required by the measurement, like a detector firing a photon at an electron, is significant enough to fundamentally alter the system state. Okay, the result is in the double slit experiment. If you try to observe, you measure it, the slit becomes a particle and destroys the wave interference pattern. However, the observer is not a person's consciousness, but rather the physical interaction of the measuring instrument with the quantum entity. So no, it says no. No. Perplexity. I asked twice. Have you interacted before? I don't have a memory of it. Okay. Okay, now I ask you, it's not about mirrors or pattern mirrors or ordinary angles of incidence. It's about whether information about which path a particle took is obtained and how that measurement interacts with the quantum system. I ask you again. I ask you, does the observer from the experimental cause? This, by the way, says no. It's not about mirrors. The observer is not about mirrors. Short answer, no. The observer effect in double slit does not cause angles of. See, I say you. Wait, I've ever interacted. Nope, this is the first time chatted. Does the observer from the slit experiment cause this correct question that we just look, the angle of incidence equals the angle of reflection. This is determined by the laws of reflection, not by observation. I ask a question, yes or no, then explain it. No, the observer in the double slit experiment does not cause the angles of incidence in classical physics. The observer effects in quantum mechanics is a different concept from classical physics laws like reflection and refraction. I told you, okay. I already explained in 20 minutes. 20 minutes too long.